This is just a quick video on linear relations. It was in the Unit 3 algebra topic, and it's just a quick video to go over all the concepts that we learned in this unit. And if you have any trouble with any of them, just go back into the content and look up a more detailed video. So we talked about linear versus nonlinear. So if you had a graph, a linear graph would be a straight line. It could be going like that. It could be, It could be this direction. It could be up and down, as long as it's a straight line. And a nonlinear graph would just be a line that's not, a graph that's not straight. So it could be a curve. And then we talked about tables of values. How do you know if they're linear or nonlinear? So a table is going to have the same first differences. So if you look at the y values, these y values are all going down by 2 every time. So the first differences are -2. So that makes it linear. It's increasing or decreasing by the same amount each time. For nonlinear, if you look at the y values, they are not going up or down by the same amount each time. So this one's going up by 1, then it's going up by 3, then it's going up by 5. So these are not the same. So that makes it nonlinear. It's not increasing or decreasing by a constant amount. And then when you look at the equations, the linear one, for all the x and y values, it's called a degree 1 function. So there's no exponents, there's no square root, there's nothing weird. It's just an x and a y. And it doesn't even have to have an x and a y. It could just have an x, like x equals 3. That's linear. Y equals 4. It just can't have an exponent on the x or the y. So if you have an equation like y equals x squared, that's going to be nonlinear. It's a degree 2 function. Or if you had an equation like y equals the square root of x. Okay, so that's linear and nonlinear. Then we also looked at linear patterns. So if you have a pattern like this, where it's going, you have 3 tiles, then you have 5 tiles, and then you have 7 tiles, we can tell it's linear because it's increasing by a constant amount. So this looks like it's going up by 2 tiles every time. So we could graph a linear pattern. We could write the equation of a linear pattern. We could figure out how many tiles there will be at term 4, term 5, term 20. And we can do that by just seeing what the pattern is composed of. So if it's going up by 2 every time, that means the rate of change or the slope of the pattern is 2. If we were to back it up to see how many tiles there are at term 0, so if I were to take 2 tiles away from term 1, I can see that there's only 1 tile there. So I know that my initial value, or my y-intercept, must be 1 tile. So I could write the equation of this relationship as number of tiles equals 2 times the term number plus 1, or y equals 2x plus 1. So this is like our pattern rule. So let's test it out. At term 3, if we want to know how many tiles there are, I know there's 7 tiles, but let's see if our rule works. So I would times my term number by 3. I would times my term number by 2. So 3 times 2 is 6, and then I would just add 1. 7, and that's how many tiles I have. So if I want to know how many tiles there would be at let's try term 4. 2 times 4 is 8, plus 1 would be 9. There'd be 9 tiles. That makes sense because it's going up by 2s. And we could even jump over to term 20. So 20 times 2 is 40, plus 1, there would be 41 tiles. So those are linear patterns. We also looked at equations. So if we wanted to write the equation of a line, we learned that it'd be nice if we knew the slope and the y-intercept. So we can find the y-intercept by looking at the y-axis and seeing where our line intercepts that. So right here at -2 is where our y-intercept is. And then we can easily find the slope by just picking 2 points on our line. So let's say I picked the y-intercept and the x-intercept. And then I can just see, I know my slope is equal to rise divided by run. So I just see, what is it going up by? 1, 2. And then what is it going over by? 1. So my slope is 2 over 1, or just 2. So if I want to write the equation of this, I always write the equation in y equals mx plus b form, where m is our slope and b is our y-intercept. So I can say my equation is y equals 2x minus 2. Let's do the same thing for a table. So I can find a slope and a y-intercept from a table as well. So for the slope, this is kind of like my rise and this is my run. So I can see that my y values are going up by 15 every time. And my x values are going up by 10 every time. So my slope is, if I'm doing rise divided by run, my slope is 15 over 10. Or I could write that as, they're both divisible by 5, so I could say 3 over 2. Or I could actually write it as a decimal, like 1.5. Any of those are fine. My y-intercept is when x equals 0. So if I just backed it up 10, then I would have to back up my y 15. So that would be at 10. So I know my y-intercept must be at 10. So my equation is y equals 3 over 2x plus 10. Y equals mx plus b. Sometimes we're given the equation and we have to figure out what the slope and y-intercept is. So obviously it's really easy if it looks like y equals 3x plus 4. We can easily see that this is the slope and this is the y-intercept. It's in slope-intercept form. But if it's all jumbled up like this, we need to rearrange this equation. So I want to keep this where it is, but I want to move the 10x to the other side. So I'm going to subtract 10x from both sides so that it goes away from that side. So I'm left with 2y equals negative 10x minus 12. And then I'm almost good. I just want to get the y alone. So I'm going to divide both sides by 2. Because that way those cancel out. So now I'm just left with y equals, now I'm going to divide both of those by 2. So negative 5x minus 6. So I know that my slope is going to be negative 5 and my y-intercept is negative 6. We also briefly looked at vertical and horizontal lines. And vertical and horizontal lines are when you're just going to write them as x equals something and y equals something. So for the vertical line, see how it just goes through 2? So you're just going to write x equals 2. Because literally that's all x is ever going to be. It's only going to be 2. And the y values don't matter. They change all the time, but x is always 2. And for a horizontal line, here we're at negative 3. So we just write it as y equals negative 3 because that's what y is always going to be. X constantly changes, but y is negative 3. So that's how you write the equations of vertical and horizontal lines. And that's just a very brief summary of linear relations.